Hello, so we are doing Geometry Chapter 2.2, Inductive and Deductive Reasonings. So there are a lot of concepts in this class, in this section. So we'll do one concept and the problem and the other concepts. Okay. So conjecture is an unproven statement that is just based on observations. And inductive reasoning, it's a method of reasoning that involves drawing general conclusions from specific observations. So let's do some problems, then it will be more clear. So this is a question 9 of the book. Make and test a conjecture. So the product of any two even numbers. So the product of any two numbers, even numbers, is also a even number. That is a conjecture, and we have to test it. So let's do. So the conjecture here is for the product of any two even integers is the product of any two even integers is an even integer. And if we do the tests, we can see 2 times 8 both are even, and the product is also even, and product of 20 and 12, which is even, is the answer is also the product is also even of two even integers. Okay, let's do the next problem. Now the next question is the sum of an even integer and an odd integer, and we have to write a conjecture based on this and test it. So the conjecture is the sum of an even integer and an odd integer is an odd integer. Let's test it. So if we take 3 plus 4 is equal to 7. Okay. The one is an odd integer and one is the even integer. And we see that 7 is a odd integer. Then we can take 4, which is a even, and odd, which is a 9. So this will give us 13. Okay, so that is also an odd integer. So when we find a conjecture, we believe that conjecture must be true for all cases. But we can show that conjecture is false by finding a counterexample. So counterexample is a specific case for which conjecture is false. And let's do some problems. So this is a statement given like the product of two positive numbers is always greater than either number. And we have to find a counterexample. So counter example we can take is like half is a positive number. Another number is 1 by 6 we can take. And if we multiply this, we can get 1 by 12. So we can say that 1 by 12 is less than half, and also 1 by 12 is less than 1 by 6. Okay. So the product of two positive numbers, it is not always greater than, we can have a like this 2 times 6 is 12. That is okay, means 12 is greater than 2 and 6. But this is a counter example. So this conjecture is not true. Okay. And this is a counter example. Let's do one more problem. So this is a question given that if n is a non-zero integer, then n plus 1 is always greater than 1. So we can check here for some number like 2 and n is equal to 2, and we see that 2 plus 1 is great over 2. So this is 3 by 2, which is greater than 1. But we have to find a counter example. So let's see. So if we put n is equal to -1, okay, because that is also a non-zero integer, and then n plus 1 over n will be -1 plus 1 over -1. So this will give us 0. And 0 is not greater than 1. So this is our counter example. It may be true for cases like this, but when we put n is equal to -1, this is not true. So this is a counter example. Counter example means it says that it is an example which says that the converse, the conjecture is not true. Okay. Let's do more problems. So deductive reasoning, it is a reasoning based on accepted facts, definitions, properties. Like in inductive reasoning, it was like we use specific examples and patterns to form a conjecture, but deductive is based fact, means it can be proved. It is based on the facts and definitions. So law of detachment says that if the hypothesis of a true conditional statement is true, then the conclusion is also true. So in this question, we have to use the law of detachment to determine what we can conclude from the information. We have to write conclusion, okay, using the law of detachment. So the question here says that you pass the final. If you pass the final, then you pass the class. You passed the final. So what will be the conclusion based on law of detachment? Law of detachment says if the hypothesis of a true conditional statement is true, then conclusion is also true. So here, if you pass the final, that is the hypothesis, and the conclusion is if you pass the final, that is a hypothesis, then you pass the class, that is the conclusion. Now it is you passed the final. It means the conclusion will be that you passed the class. So using law of detachment, if the hypothesis of a true conditional statement is true, then conclusion is also true. So the conclusion will be you passed the class. So this is the question or the statement given. If your parents let you borrow the car, then you will go to the movies with your friend. You will go to movies with your friend. So what is the conclusion here? Do you use the law of detachment? But we cannot use in this case because it's not possible. You may get to movies by other means. So if you will go to movies with your friends, it doesn't we cannot conclude that the parents let you borrow the car, because you may get to movies by other means also. So there is the law of syllogism, which says that if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. And if these are true, these statements are true, then if hypothesis P, then conclusion R. Okay, then this statement will be true. If both of these are true, then this will be true. Like if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. If these are true, then if hypothesis P, then conclusion R will be true. So let's do some problems. So in this question, we have to use the law of syllogism and write the conditional statement like this, the last one, if possible. Okay. So if if suppose this is P, then Q. Okay. And if this is suppose, because this is different from all, this is R, and this is again Q. So our statements are like, so this is PQ, this statement, if P then Q, and this is if R then Q, so RQ. So this doesn't match here, law of syllogism, because it was PQ, QR, and then it was QR. So it is not possible that we use law of syllogism here, because this is different. This is PQ and this is RQ. Okay, so this is not possible. So the conclusion of first statement should match the hypothesis of the second statement. Okay, so conclusion of first statement here doesn't match the hypothesis of the second statement. So we cannot use law of syllogism here. So here it is given, if A is equal to 3, then 5A is equal to 15. And if A by 2 is 3 by 2, then A is equal to 3. So if we have to use the law of syllogism, we can little bit rearrange it, because we know it is like P to Q, Q to R, and then we can write the conditional statement P to R. So if we rearrange it, we make this P, this Q, and this portion A is equal to 3Q, then this will be R. So if P, then Q, if Q, then R. So we can a little rearrange and we can use the law of syllogism. So this will give us, if P then is equal to 3 by 2, then A is equal to 3. So if we put this as P, okay, if and then Q, if this is Q, we have rearranged it. If Q, then this is R. Okay, so if P, then Q, if Q, then R. So here we see that conclusion of the first statement matches with the hypothesis of the first statement. Okay, so So if P then Q, if Q then R, then we can write if P then R. Okay, so it will be if half A is 3 by 2, or we can write exactly, it is given 1 by 2. Okay, then R, which is 5A, is equal to 15. So this is using law of syllogism. We have written this is the conclusion. And we could use this law of syllogism here because Q of the first statement or the conclusion of the first statement matched with the hypothesis of the second statement. Okay. Okay. So we in the 21st question, question 21, we couldn't use because conclusion of the first statement does not match with the hypothesis of the second statement. But here the conclusion of the first, we rearranged little bit and we saw that conclusion of the first statement, like Q of the first statement, matched with the hypothesis of the second statement. So if P then Q, if Q then R, and we use the law of syllogism. Okay. Now let's do next questions. So this is question 25 and we have to write whether which law of logic is used, whether it is law of detachment or syllogism. So if you do your homework, this and then you can watch TV. If you watch TV, then you can watch your favorite show. And the conclusion is written, if you do your homework, then you can watch your favorite show. So if we write the answer, P here is homework. Okay. So this is PQ. So P is the homework. So in this question, we had to find the law of logic used. If you do homework, you can watch TV. If you watch TV, then you can watch your favorite show. And this is the conclusion. So if you do your homework, then you can watch your show. So statement was one was if P then Q, then if Q then R, and conclusion is if P homework, then R is a favorite show. So we can say that here it is law of syllogism was used. Okay, so we had to find which law of logic was used, whether law of detachment or syllogism. So this is a question. If you miss practice the day before a game, then you will not be a starting player in the game. You miss practice on Tuesday, you will not start the game on Wednesday. And you have to use like what law of detachment or law of syllogism is used in this. Okay, so as per the definition of law of detachment, we see that the if the hypothesis of a true conditional statement is true, then the conclusion is also true. So we can see that this is an example of deductive reasoning using the law of detachment. So here it is, if you miss practice on the day before the exam, then you will not be a starting player in the game. So this is if this is a rule. Okay, here this is if P, this is P, okay, and this is Q. Okay, so this is a rule, if P then Q. Okay, now it is, this is a now the fact is here, this is a fact used that you missed a practice on Tuesday. Okay, this is P. So this is the conclusion that you will not start game on Wednesday. Okay, so this is a fact. So we are using here law of detachment used. Okay, because in a law of detachment, as we did earlier, it was if a hypothesis of a true conditional statement is true. So this was the hypothesis. If you miss the practice the day before, this was a rule given to us that if you miss the practice the day before a game, then you will not be a starting player in the game. Okay, so this was a rule given to us. Now the fact is you miss practice on Tuesday. So the conclusion here is this was a fact, and the conclusion here is you will not start the game Wednesday. So this is a example of law of detachment. So we can see that question 26, it is a law of detachment because if the hypothesis of a conditional statement is true, then the conclusion is also true. Okay, so we'll do more problems in our next class. Please keep practicing and please let me know if you need help. Thank you. Thanks for joining.